Stop. Don't click on stop broadcast. Okay. Okay, so databases, I will show you the slides. So, so what's the point of databases generally? Well, generally there are actually 2 points of databases. They're useful for 2 things normally. So one is that they give you a persistent way to store data in an organized way. And they enable you to search the data and retrieve it in an organized way. So the first point is achieving persistence of data and searchability. The other point that is really quite fundamental is to enable you to concurrently access the data. So a typical way to organize a web service, again I draw you only for the people in class, but the others can follow the voice, I guess, is this, okay? So if you're trying to do some service that is used by very many people, you have many front-end web servers. These are the servers that actually get your request, produce the HTML code that is sent back to you, etc., etc. But all of these web servers are accessing, reading, and modifying the same version of the data. So where is the data? If this is a computer, it cannot be on each one of these machines individually, right? Because if you put it on this machine, it wouldn't be readable by the other servers, okay? So the way in which you build scalable web servers, and also these might be the servers that talk to a lot of your Android apps, is that you then pull up you have one database server and you have one copy of the database, okay? So all the complication on the concurrent access, the fact that you may be selling in your web app, as a simple example is that your web app is trying to sell places on airplanes, and so you make your reservations and you sell these places, okay? So there is some concurrency issue there, that if I sell a place to some person, I should not be selling it to some other person. I mean, there is overbooking, okay? But overbooking is completely different. Overbooking by airlines is done voluntarily with sophisticated algorithms, or maybe not so sophisticated, no, I think it's sophisticated, in which they try to maximize their revenue. But the problem is that even if they do overbooking, they want control over the situation. So they want to know exactly, who is buying which seat, okay? So if you are serving concurrent web requests that are trying to reserve seats on the San Francisco to New York flights, for instance, you need at some place to do, essentially to have these synchronization primitives, right? Like we have in Java in a coarse way. In Java, you would lock the whole data structure or portions of it, but the databases can do a lot better. They're designed for that. And so they're the point where concurrency between all the different web accesses is resolved, okay? So now in Android, even though databases have these 2 functions, in Android we generally call them upon one of them only, okay? We are not using them really to resolve problems of concurrent access, because an Android is generally a single user machine, okay? So the only reason to use a database in Android is typically to achieve persistency and to be able to structure the data, okay? That's basically the only reason. And so I can tell you, before we get into these, that the way Android implements databases is by using SQLite. Okay, SQLite is a set of C code. Essentially, it's a database management system written in C, in which the whole database resides on the same file. Okay, and it is very efficient regarding speed of access to the data. You can read and write the data very, very fast, actually. Okay. What it is really not very good at is concurrent access, because essentially SQLite achieves concurrency control by locking the whole file. Okay, so there can be only one person modifying the database at the same time. This works really well for single user cases and for testing. It would work horribly bad if you wanted to implement a large-scale web service on top of that. Okay. However, to store data, it's incredibly efficient. For example, Let me just tell you this anecdote so that you can think at the advantages of using SQLite even in context where you may not otherwise have used it. Once upon a time, I was implementing an algorithm very similar to PageRank, and I had a graph description. I mean, I had a description of this graph. The graph was really quite large, you know, some billion nodes. So I could not store it in memory. I needed to read it from a file and iterate on it multiple times, reading it from the file each time. So the most trivial implementation that I tried first is that I was storing the graph as a CSV file, comma-separated values file. You know, I would have a structure similar to source node, destination node, and then you know something about you know, a nickname for the edge or whatever I had, you know, something like that. And so I would look through these list of edges, and I was doing whatever computation I was doing. Okay, and so I had a certain running time. After a while that I was doing this, I instead created an SQLite table that had basically the same structure of the file, but it had, you know, source node, destination node, and then, you know, some information associated with the edge. The difference in running time was a factor of over 10. Okay, why this? Well, basically because SQLite achieves a much better running time looping through rows of tables. Okay, I don't know if any one of you has ever traced C code or code in general while it's trying to run data files. Okay, to you it seems an absolutely trivial operation, the one of you know, reading a floating point or maybe an integer and transforming it into the integer or floating point data structure into not data structure, but, you know, representation inside a code. But if you have ever read the amount of work involved into reading a string of characters and actually parsing it as a floating point number or as an integer, there is quite a bit of work that goes into that. Okay, SQLite stores these values, you know, both strings or floating point or dates or integers in a way that is machine compatible with any architecture. You know that natively some CPUs like to store integers in different orders, right? You may have studied it in computer organization, right? But some CPUs like to store the least significant byte first, some others the most significant byte first. Okay, so there are different really CPU architectures. So if you just store bytes as they are in memory, this is not compatible across machines. So SQLite gives you a compatible binary representation of the file. You can generate the file on an ARM architecture, send it to an x86 architecture, or, you know, on an IBM architecture or whatever it is. It's always compatible, actually, the storage of the file, the storage format. Okay, so you have this beautiful portable format for the data, but you also have incredibly efficient access to the data. So you know, I very highly recommend you, if you need to write any code that needs to store and read large amounts of data, even though you might not think it's a database problem at all. Mine was not a database problem. I did not need to search or do anything sophisticated in my data. I just needed to look through it, right? Yet I really advise you to take a look at SQLite. It gives you a portable representation of the data that is incredibly more efficient to access than you know, these text representations. You know, we are looking at JSON often in this class. We look at JSON because it's portable and simple, but it's by no means efficient. So if you were trying to do the same work by having a text file in which every line of the file is decodable via JSON, you know, that would be a disaster efficiency-wise compared to SQLite. Okay, so this said, given how great SQLite is, SQLite was a project, I think it was started in Berkeley a long time ago, the code base at UC Berkeley. And then this saw more work to it, it became an open source project, and it's now a very mature and very stable code base. I think it has been going on for well over a decade, but I think more likely some 20 years in total. I'm not quite sure, okay, we should check. But so this is code that is really well tested, works really great. And so the Android designers decided that in order to let you store data, they would offer you this very simple structure of the settings, but they would also give you access to SQL databases that are actually stored via SQLite in the flash memory. Okay, and so this is a bit of the behind the scenes. SQLite is something that you can incredibly easily use yourself. So here I was playing with an example before coming to class. Okay, so let me see how to make this font larger. Okay, but here is how you can use MySQLite on a command line from a Linux machine. It works the same actually from a Mac, and Windows you can also install it. So you say SQLite mydb.sqlite. Okay, so you call it on a file. Okay. Sorry for the ding ding. I don't know what that is. It might be somebody trying to chat me. Yeah, is the TA here? No. Okay, so I don't have anybody looking at the questions and answers. Let me see if by any chance is somebody doing a quick Q&A on the Hangout. Let me keep an eye there. No. Okay, fine. So you say SQLite and then you give the name of the file. Okay. This starts the program, and then I create you can get the list of tables. Okay, sorry. So there is only a table user. I think you can do describe user. I use both SQLite and MySQL, so my mind gets confused about the set of comments. So scheme user, then it must be no. Okay, fine. I forgot. So I would have to go into the documentation to see what it is. Does anybody know, or is anybody willing to search? I can show you what I created because I just created it otherwise. But SQLite describe table. You see, a lot of people are asking because so schema, not schema. User, okay, and this gives you, so user is a table that has the name as text and the age as numeric. I just was in a hurry and I created a table with only 2 fields, okay. I inserted data in this way, insert into user name age values Luca 48.3. The age is a floating point number, okay, so you can do things like that. And then you can say, for example, select star from user. So you can use it pretty much as you can use any SQL database. So in many of these SQL databases, there is a set of command that is standard and a set of command that is non-standardized. The standard set of commands it concerns the query language. Okay, the syntax you use to insert data or select data is always standard in this SQL implementation. So there may be a very slight difference from one implementation to the other, from MySQL to Postgres to SQLite. But basically, this is defined in the SQL standard, and all these database implementation try to really follow closely the standard. The part that is not standardized and creates always problems is the syntax to actually do database maintenance operations, such as, for example, listing the set of tables. What I did in dot tables, that command is going to be different in SQLite versus Postgres or MySQL. Okay. Also, these comments to describe a structure of a single table are all different, unfortunately. Okay, so there is a standardized portion of how you interact with a database, which is the query portion and the insertion and data, the data management, all that concerns data, querying, inserting, deleting, updating is standardized. But much of what concerns database management, meaning creating and deleting databases, tables, and reorganizing them and changing their format, all of that is actually dependent on the database engine. And the dependency cuts 2 ways. Names of the commands change just to make it harder on us, I guess. No, I'm sort of kidding. But the other problem is that databases really sometimes give you a different set of commands to alter the data that you have already in the database. Okay, so For example, Postgres and MySQL, that are two of the most common open source databases, differ in the way you can alter the format of tables. You know, there are subtle differences here and there. I don't want to go too much into that because it's not a class on databases. But so this is a situation, you know, a uniform query language and different management comments. Okay. Again, SQLite is incredibly useful, and for most programming languages, you have wrappers on top of MySQLite, on top of SQLite. Sorry. So, for example, there are beautiful Python binders, or you know, half beautiful. I'm not sure. There is a Java binders. There is a C interface, of course, and etc. etc. Okay. So very good to know. How many of you have really used databases in your work before? Raise your hand if you have. So some of you, but not too many, which is, I think, the typical situation in the classes I teach. I think databases are one of the truly great things to know and essentially achievements of computer science. You know, there are some of these things that really there is research on how to do them better for some situation, but essentially they have been done so well that in a way they are not taught and they don't occupy enough of the mental space. You know, one is databases, and by now, you know, if you need reasonably sized databases, I mean, you have incredibly good tools available and they just work. They just work and they work well. Another fantastic achievement of computer science has been the theory of compilers, for instance. By now, people know, you know, if you go some years, decades in the past, it was harder to define how to go from a language written in front of you to a representation that you could actually then compile to executable code. Now that whole theory has been done so incredibly well that it's almost less important to teach it, you know. It's almost not a research area anymore, except for some strange languages. So myself, you know, I had to write several compilers, not for executable languages of the sense you imagine, but more for like languages that would be translated in logic or in other things, right, or in automata or in various things. But again, it's one of these things that used to be a very hard problem and now is so well understood that they became more of a tool than anything else. And databases are one of those. And databases, if you go out of the university and into the sort of the real world, they play an incredibly important role. That's why it's very useful that to know them. Okay. Oh, I see who is chatting me, as one of my students. So let me continue the presentation, which must have disappeared somewhere. No. Okay. So in MySQL, in Android, when you want to open a database, the good process to do is to actually use an SQLite Open Helpers. This is a class that you subclass in which you define your own way to open it. So you know, this is the Java way of living, right? Whatever you want to do, you subclass a class and then you extend it in the proper way. But aside from this being the Java way of living, there are some advantages. Namely, if you really do an app that contains a database, you have some slight problems, okay? So the problems are, well, this might be the first time the user opens the app, in which case I need to actually create the database. But if not, if the database is already there, I should just, you know, use it. Also, eventually I'm going to have another version of my app. It's going to be version 2, perhaps, no? And in version 2, maybe I need a different database. And so I need to essentially check what is the version of the database, and if it's the old version, somehow update it before I let the user use it. You know? There are all these sort of kind of boring maintenance issues. And this database open helper helps you deal with them. So what you do is that you define a database version. You define essentially a string, dictionary table creator. This is just a a string that if you give it to to SQLite, it will create the right database for you. Okay, so you see this is just like pasting pieces of a string. It's kind of horrible, but you define it only once. You know, it's essentially you try to define the database on a test machine, and then you cut and paste there what you want to do. Okay, and so what you do is that you override on create and you override I mean, this is a very simple override. I have an example later in which the override is more complicated. I want to show you a more complicated override later, okay? But essentially, this is the simplest possible thing in which you override on create, and otherwise you just call super because you don't want to do anything special, okay? So once you have a data, once you override that, that class gives you two methods: get readable database and get writable database. I think most often you want a writable database. A readable database would be a database from which you can read and not write. And I never had a use for such a thing. Normally, I just want to do both. Okay, so I'm not quite sure why it's given to you. You can open a database directly if you really want. I won't tell you how because you can read it. Once you have the database, you can call this method on the database object that is returned to you by getWritable database. This is a query method, okay, that has a lot of options. So in SQLite, sorry, I always call it MySQLite, making a mix of SQLite and MySQL. So in SQLite, you can just type in a query like this, okay? And if I wanted to insert more data, let me insert another data. Insert into, let me see how the syntax, user, name, age, values, I don't know, George, I have this George for me is like John Smith, and you know, 23.4, whatever. Okay, and so if I select all the data from user, I can get 2 rows now, you know, big deal, great. But this is, of course, a fine way to query the database, and one of the things that makes databases fantastic, by the way, is that they're so easy to debug, right? Because you can write very quickly in another window, type queries, and get content from them. So, but this is fine in an interactive setting. But if you want to query them from code, the typical way you do is this: you build a query, so you send it to a query, and what you get as a return value is an iterator that is able to iterate on all the rows of the result. You know, each one of these is a row. Luca 48.3 is a row, George 23.4 is another row. Okay, so that's how it works. So if you go to, where does my slide go? Okay, so the query here returns a cursor. Okay, where cursor is something that you can iterate on. What was that? Oh, I have, you know, okay, Google. Yeah, but unfortunately my phone locks, and so it all me says is speak, please say your PIN, which is not very useful. I guess I could say my PIN, but so anyway, time I say something similar to okay Google, what time is it?
Say or type PIN code.
You could tell me. Okay, fine. So I have this query object on which I will be able to iterate, okay? But then I have to tell it essentially all the pieces of the query. I have to tell it whether I want distinct results, you know, or whether I allow duplicated rows in the result. I need to give it the table, which is a string, it's the name of the table, right? I have to give it an array of strings that denotes which columns I actually want to get, okay? Then I have to say what data I want. This is string selection. This is an array of selection arguments. I will tell you later why I have to give first the selection string and then the selection arguments separate, rather than saying, you know, where. Let me do a query here that contains a selection, okay? Like from user where age is greater than 30, okay? So this age greater than 30 is the selection. Here I'm giving it all at once as a single string, right? There, I will have to give you something different. I will have to say that the selection string is age greater than question mark. This will be the selection string. and then I will have to separately pass to the database engine 30 as the value that will be replacing the question mark in the actual query. So this is more complicated, and I will tell you exactly why you need to do that, because there is a very interesting class of problems that arises if you take a shortcut and include the data in your query directly. Okay, group by, having, order by, these are database parameters. You can always say when you do a query how you want the data to be ordered on output. Okay, for example, here I can say select everything from user or order by age descending or ascending. I always forget. Okay, ascending, I got it right. Or I can say descending and I get the other order. Okay, so okay, this is kind of getting annoying. I don't know. Hello. Let's put it back. Okay, so a bad example would be this, okay, in which I build my query string by say the where string is key column 3 plus equals plus the required value. So I'm really assembling the query as in sort of I say query is equal to name equals plus name, where name is a variable that I may have. Okay, so in this bad example, I'm really building the query string by concatenating strings. So this is something that some people do. I've seen it in a lot of code actually. Why is this incredibly bad? Because of this. So this is XKCD, and I think it's the best explanation. He's genius in explaining complicated things simply. So I think you can just read it. Okay, you get it, right? Essentially, in computer science, there are two great ways to shoot yourself in the foot. Okay, one is one is quoting, and the other way is buffer overflows. I think you all have seen buffer overflows in action in the Heartbleed bug, right? So that's a typical one. And this has, buffer overflows has been by and large solved by using better languages, but it's still there in C, of course. So C in truth is a really poor language in which to write applications that are security critical. The other problem in computer science is quoting, right? So here you want a string that will contain a name is equal to Luca if you're searching for Luca. But if you're searching for a student named in that crazy way, then this Robert and then that closed bracket, these would have been to be back quoted, okay, and then maybe also these would need to be back quoted. I don't know exactly the rule. At least these would need to be back quoted. At least the quote needs to be back quoted, okay, so that it's interpreted not as the fact that the query string is finished, but that there is a quote in the element you are searching for, okay. So quotation is one of the nightmares, and it's a nightmare basically because the data you get looks like a string. So you never know in your application where exactly it has been quoted already or whether you still have to quote it, right? So if you do it by hand, it's very easy to get it wrong. So the way to get it right is to not take care of quoting explicitly yourself. It's much easier to actually use the recommended method in which I give you the selection and then I give you the arguments, and the selection never contains the arguments itself, or you never try to concatenate yourself, but it contains these question marks, and then the call to this query method will worry about doing the right quotation. Okay, so a good example is like this. The string where, so the where clause is key column 3, so the name of the third column, plus equals question mark. So essentially the good way to write this would be to say that this is this only, okay, and then you can give the parameters of the query later, okay. And so this seems silly, but But this is, to this day, one of the main causes of vulnerability of websites. The passwords and login details of people in the PlayStation network were gotten via an attack of this kind. Yeah? This question mark is like a placeholder that says, here I need argument number 1. And then if in the argument list I give you, a string that says Luca with a quote in it, if I give you this, essentially, it would take this string, replace it for the question mark, but apply the proper quoting. So it's like in a printf, you would have, this %s, for strings. And then they call it question mark. But it's a similar idea. Okay. So once you have once you do this query method and you specify this long string of this long list of arguments, what you get back is a cursor. When you have a cursor, you can do various things to it, which is, the most important are these ones. Move to next, essentially, is by far the most important. Okay, because move to next moves you to the next row of the result, and it returns true or false depending on whether there is a next row of a result. Okay, and then you can. Okay. Okay, so this is a typical code. Okay, cursor my gold. I copied this example from somewhere, but is equal to my database.query. In which I just specify the column, the table name, and leave the rest blank. This just says, iterate on all the elements of the table. Okay, and then if I say if my gold moved to first, so if I succeed in moving to the first element of the result, this means essentially if the result is set is non-empty, right? Then I can do the following. I can you get float gets the floating point value of a column whose name you specify as argument. Okay, so this gold hoarded column is the name of the column that contains these gold hoards. Okay, and my gold.getFloat would give you the floating point value of these. I mean, I could say like my cursor.getFloat of column age, in the example that I was having in MySQL. In SQLite before, okay? I don't know, here I'm computing the total gold you have, and then you say, while my gold.move to next. So you are moving to the next row if there is one. This is a typical pattern for you to iterate on the elements of a cursor, okay? And so...
Try again.
Okay. Maybe I should switch it off, or maybe I should just move it away. No, there is a complicated story, but I will tell you at the end when I stop the recording. Okay. So there is new values put. This is how you insert values, and this is basically. So to insert values is also a little bit boring. I don't know. I find that Java, inserts these layers of. It's like a language that is too politically correct. There is always a super proper way of doing things. And so here, the politically correct way to insert values is not to give an array of whatever, because in Java you cannot have an array of things that are of different types. That's a problem fundamentally. So what can you do instead? Well, you have to say content values. New values is equal to new content values, where content values is this container structure. So you are trying to form a row, right? So you first get this container element, then you have to put one by one the values into it. So you put, you do a put in which the first argument is the name of the column, and in the second argument is actually the value. It's a little bit like writing the settings, It's like a value key association, a key value association, So the key is the column name, and the value is the value you want to write, because this allows you to have values that are of different types one from the other, okay? And once you put all the values, you insert in the database table the values, the row that you have produced, okay? So it's not too cumbersome, but in Java you need to do this. In Python, the interface to SQLite is simpler because since in Python you can have tuples of things of different types, you can just specify a tuple and say insert it. Okay, you can update, you can delete, and you can also execute non-query statements such as creating tables or updating them. Okay, so basically you have the whole interface. And so as usual, you know, these database operations may take some time. So if they're absolutely trivial, you can do them in the UI thread. If they're not trivial because you need to scan a whole database for a big set of values, then you need to create a separate thread. Unfortunate, but true. Okay? Displaying query results, I don't want to go over it because I think we did enough in other classes, or I mean in other lectures on how to build this list of results, etc., etc. I wanted to show to you a tutorial on this. I will link to it. No, sorry, this is not it. This is it. I mean, the other one is also a tutorial, but it's not the one I wanted. So these tutorials by Fogella, some of them are good actually. So if you see them, they're not bad. I think that here, what I wanted to, sorry, I'm way below in the tutorial. I wanted to show you how to create what he does for creating the database. So sorry, I lost track in here. This is already the cursor. Okay, this is what I wanted to show you. So this is a class that he named MySQLite Helper that extends SQLite Helper. Okay, so usually people define as constants in Java these names of the columns and the comments to create the table. Okay, and the only interesting thing that I wanted to show you is this here. You need to give an onCreate method, which typically is very simple because you have built your string to create the database, and so all you say is that onCreate database exec my onCreate string, and that's fine. There is not so much different. The interesting thing is this. This is really where, in my opinion, is the power of using this helper. There is this onUpgrade, in which it gives you the database and it tells you the number of the old version and the number of the new version. Notice why this is beautiful, okay? Because here, we just say private static final int database version is equal to 1, okay? And we just use this database version in this super call when we create the object, okay, of the class. So that's all where we use it. Yet, this call to onUpgrade is managed for us. What I want to underline is essentially this, that if we have to manage it ourselves, we would have to figure out how to associate a version number with a database file. And then we would have to remember every time we open the database to actually check that the version number is the same version we expect. And if it's not the same version, then we would call this piece of code. And here instead, all this complication is essentially managed for you. All you need to do is put in this function that updates the database format. And this seems like a detail, but if you develop anything serious, you know that the database format will not stay the same for very long. You always need to update it because you always change your mind on exactly what you are storing. Okay, so this is incredibly important that the migrations are well managed. Otherwise, it would be a fantastic way of annoying your users because you crash the app from when you update from one version to the other that needs something different. Okay, so this is essentially what I wanted to show to you. And otherwise, what else can I say? This works quite well. many of the things that you see on your phone, such as your contact list, the list of photos you have taken, all these kind of things are kept in databases, in SQLite databases on the phone. So this is as much as I wanted to say on databases. There is a lot more to say on how to organize data, but I'm not sure you are interested. Do you have questions on databases, or would you like me to do anything special on databases? Yeah?
In the Super Bowl, when they create the like constructor, how are they doing so many things? Like, isn't a super usually like defined kind of strictly, like the super call for MySQL, or like how is that in your constructor for this object? Like, is that a super for the MySQL?
This is so super gets these arguments, okay, and this means that the class SQLite open helper has an initialization method that gets all those arguments. I suspect that the superclass has also initialization methods that might get fewer arguments to make it simpler for you sometimes to open, okay? But this code uses that particular code, yeah. Other questions? Okay, so somebody was asking how to store geographical data. Is this of interest to any of you? I talked about it already a little bit at the beginning of class, but would you like me to answer it now? How to store geolocations? No, as you like, or else do you have other questions? Otherwise, what I thought I was doing was telling you, trying to solve the server problem for people who needed it. I mean, how many people needed to have a server component developed for the project? Okay, so do you know how to develop it already or not? Okay, great. I mean, great for the people who know. For the people who don't know, would you like me to help build some of it now? Would that be the most useful thing that I can do for you now, or what? Sorry?
Yes.
Okay, great. So let's do it then. What kind of data do you need to store? There are two groups here, right? There is you and them. I don't know if them is one group or multiple groups, actually. Okay. So I don't know. Let's go. I don't know. In some order, you decide. Who wants to go explain first of what you want to store?
Part of it is storing pictures.
Okay.
It's like a picture that's sent between users.
Okay.
I think you kind of covered doing a chat system lecture, but I'm not sure.
Yes, but a picture is different. Okay, let me see what is the other question, whether it's simpler than pictures, and then, otherwise I can tell you about pictures. But pictures is sort of, has some complicated part to it. What do you need to store instead, you?
Let's see, a couple lists that are just objects filled with like strings and latitude, longitude locations.
So a typical row would have something like, because this is not visible to the user, so we don't need to have super fancy names for rows. So we can say, for example, that the table may be called location, and that the rows are, I don't know, like name. We can have name, lat, and longitude. Okay. Would this fit? Would this? And how do you plan to search? What are the search operations you need on these?
I don't know if we had search operations on that plan.
No, but if you only store things, that's what I do. With a lot of my calendar is write only, and then I forget about things. I'm joking. I'm not joking, but but I mean, if you only store things, it's not very useful not to have a database. I can give you a very simple implementation in that case.
I was thinking about like retrieving these lists to the phone at the beginning of the app so that they can display all the various locations.
So essentially you want to read everything.
Quite possibly.
Okay, I mean, that's not so, I mean, as long as you don't have a lot of data. If you have more data, that doesn't work very well. So let me do a brief parenthesis. How do you store geographical data if you have to do it? Okay, let me just mention it quickly. Okay, I'll try not to spend more than 2 minutes, 5 minutes perhaps. But so in computer science, they invented a lot of very fancy approaches of indexing bidimensional structures. Yeah, I think I mentioned to you these quad trees that are like binary trees. A binary tree, every node is split in one dimension only. You know, you have a value and you can be either greater or smaller. Okay, in a quad tree, every node splits. If it's a 2-dimensional quad tree, you know, every node splits into 4 quadrants, greater than or smaller than in each one of the dimensions, essentially. So if you do this, you know, you can essentially do a balanced quad trees that can store n-dimensional data while preserving topological continuity, etc., etc. Okay, so this would, you know, would enable you to do a search for, you know, any rectangle in lat longitude. But the fact is that this is not often. I mean, I haven't seen it often used, and the reason is that. When you use a database engine, typically you're given a database engine, and if the database engine supports bidimensional data, then you are fine. But if it doesn't, you cannot really re-implement you know, quad trees just to store geographical data. So what are other solutions? There are many, but one that is particularly simple, and I just want to give you is this. You start by saying, fine, I have some function that I call h0, that given a latitude and a longitude, it gives me an integer I that is the name of the square, essentially, where I write the information for this latitude and longitude. So you do squares that are maybe 1 mile in radius in edge, okay, and then when you want to read something, you know, you can just read everything that is in the square number called I. And you make sure that the squares are small enough so that even if you read them all, you don't waste so much time. No? I don't know whether 1 mile is the right size of a square, but you just make them small enough so that, you know, you might have like 20 data points in each square, and then you don't care if you read the 20 data points because they're written contiguously in some way, and really the access time is not a problem. Okay? Fine. Now, this works really poorly if you have a one square mile grid, and then you want to ask, you know, what are the list of, you know, I don't know, but what are the, suppose that you have an index of all the, I don't know what a good example is, but of all the Starbucks, you know, of all the locations of all the mailboxes in the whole of California, and then you ask for a map of the whole of all the mailboxes in California. Then you have to read an incredible number of these squares. So let's you know, the typical query you want to do, suppose, is where do I go post my letter, no? And so if you know your location, in this way you have to at most read 4 squares, no? Because if in the bad case, even if you can walk only maybe half a mile, in the unlucky case you are close to an edge of these squares, and so you have to query 4 of them. Okay, that's not so bad. You know, you read 4 times the content of a square. Now, the typical solution is this: you keep in your data points not only the latitude and longitude and the name of what you are keeping, but you are keeping an index that is in part I don't know how to call it, but P, let's call it P. It means the prominence. If it's the prominence is the biggest square at which you should be still seeing this data. Let me explain. This is H0, I called it. Okay, then you define similar functions H1, H2. Each one of these is like a zoom level in Google Maps. Actually, in Google Maps, the bigger the number, the more you zoom. But this, imagine that you're zooming up. Okay. So H0 gives you the full detail. H1 could use squares that might be double the edge. Okay, so they contain 4 times as many points. Okay, H2 would use squares that are even bigger. Okay, so you have a hierarchy of squares. It's as if you don't have a database, single database. You have many databases, each one has a different resolution. And for each place, you know how important it is. For example, if you're doing a database of, say, cities, you know, there are some cities that you see only if you zoom in totally, because they may have, you know, 120 inhabitants lost in the middle of nowhere. So unless you zoom in, you shouldn't be seeing them very much, okay? Especially if they're around, there are a lot of other cities. But there are cities that even if you zoom out, you should see, and so they have a very high importance, and they appear in many zoom levels, okay? Los Angeles would be one of them, or San Francisco, okay? So if you update something that has to do with a city or with a mailbox, you need to update all the squares where the city appears. So there is a repetition of data, okay? But this is not as bad as it seems, because you know, this is a classical thing in which you have a lot of data in the table H0. But in the table H1, you only have a fourth of this data, no? Because the resolution here is 4 times larger, and so you decide that only 1/4 of your H0 data is important enough to be included in H1, because you want to maintain, you know, the same visual density for the data, no? The same for H2. It contains only 1/4 of the data in H1. So if you update a data point at random, what's the average number of updates of tables that you have to update? The average is very close to 1, actually. Because it's true, for some data you have to update many tables, but that data is very unlikely. There is very few data that is important enough to appear in many tables, okay? So even though in the worst case you may have to update many zoom levels, even updating, you know, 15 zoom levels is not so bad. And then at least in the average case you are very fast, but you can decide based on the zoom level you have which tables you have to update. I mean, which tables you have to look up from. And so this is a very simple scheme. So, you know, if you wanted to use something like this for your app, you could, you know, divide the data in some grids, and then, you know, and then just read from those grids. And the way you could store it, I mean, the way your table could look like in practice is something like this. You would have a name, latitude, longitude. I mean, this would be not a perfect way to do it. It's like a quick and dirty semi way of doing it. But then you would have the H0 in integer, the H1 index, and the H2 index. Okay, and this can be null. Okay, so if you are looking at resolution 0, and you want every business that is called Starbucks and is in the square 317, you can get it by searching for equality on the name and on the index number. And this gives you an efficient retrieval. Okay? Not incredibly sophisticated, but it works. Okay? So this is one possible way of doing it. Okay, so now in practice, what I would advise you, because it's your case is more simple, okay, would be to take the class example we had. Sorry if I have this thing here. I don't know what it is. I think we had this class example in which we had models, and here we had the tables, okay? So this was for, and we could use db define table, like location, okay? And we would have various names, so field name, and these I can leave it just like this, because by default in Web2Py, if I don't say absolutely anything, the field is going to be a string of at most length 512. So I think that's approximately what you want. Okay. Then I can say field latitude, and this can be double, and that's all it takes. Okay. Field longitude. I just hate that they're not the same length. Double. Okay. So this would give you the table, and then we would need to go into the controllers. Into the we can make a new controller, for example, not to create confusion with the controllers that are already there. Okay. So I can create a new, and I can call the new controller. What's the name of your app?
CSC.
Okay, and so yeah, here I don't need to write anything, but and so you would need what methods? You need at least one method to insert a single data value, and a method to read them all, I guess. Okay, so let's start. Actually, I wanted to look at this code that I wrote previously. Okay, so do we need to verify users? No. Okay, I just wanted to copy this code. Okay, so we have a secret, which is again be happy, but you may want to change it. Okay, I want to import JSON to be able to produce the output that you actually want. Okay, and then let me copy this code, and then we just fix it. Okay, that's the way fastest way to write code. Define put, we can call it insert, because so it's a bit nicer. So you will give me a string of the format. Let's write it here what you're gonna give me, okay? Format. And you're gonna give me a secret. You're going to give me a secret. You're going to give me a name, and you're going to give me a lat and a longitude. And I'm and you are going to give these things to me as variables, okay? I say as variables because there are two ways of passing things to Web2Py. One is as URL components, and the other thing as variable. A variable means, you know, that you have the URL, and then you have this question mark, and you can say secret is equal to Boeing, and you can define variables in this way. Or else, I think I gave you an example previously in the class. You can also do these using post requests. I think that the code that I gave you, for example, in the class, actually uses post requests. Is that correct? I think it is. So, and in post requests, then you can, you know, you can also insert variables there. So I think variables is slightly more flexible. And so I can say request.vars.secret. Okay, if secret is different from my secret, I return an error. App ID, we don't need it in this case, okay, because I'm building it just for you, actually. Name is equal to request.vars.name. Okay, lat is equal to float of request vars lat. Longitude is equal to float of request.vars.longitude. Okay, so of course here I would need really to say something like try. Okay, except these ways. Okay, because I don't know that you are giving me values that are floating point numbers or whatever. So I can do these, and then I can say db store db store. Okay, so are the names unique or not? Because otherwise, what happens if you add the two things with the same name? Probably bad things. So can I assume that the names are unique? Okay, if not, you have to tell me with something else that is unique, because update or insert of db, so db is not called store, it's called location. Update of insert db.location name is equal to name. This is the clause for uniqueness, and then I can say name is equal to name. Lat is equal to lat, longitude is equal to longitude, okay? So I can do these, and then just return that you succeeded. So this is one method that I can do for you, okay? And the def get all, okay, and so here the format in as variables, and here is you just will pass me the secret, okay? So I can copy a bit of code that verifies the secret, and then I can say rows is equal to db locations no, sorry, db locations location all select. Okay, and I say as list. This will produce a list for you. Okay, and then I can simply say return dictionary result is equal to rows, and a list can be turned into JSON, and so that's all there is to it. Okay, so I don't want to check that this code works now, because I don't want to delay the class if I made some mistake. I can check it later, but otherwise I can post it tonight or tomorrow morning. Okay, and then you can follow the instructions that I have on the class web page on how to upload this to App Engine. So you should be in business with this simple code. And I think this gives you enough of how to modify it if you need something slightly different. Does this put you on the right track at least?
Perhaps.
Perhaps. Okay. If you can think of things that for which this doesn't work, we can.
I probably just need to add more to it. Show everything we're going to be doing the server.
Right.
So,
But would this help you at least to get started? And if not, come with questions next time. I mean, I really sort of, this last class, as I mentioned, I want to help you do the projects. So now, pictures. Pictures are slightly more difficult. Okay. Why? So. Because of two reasons. First of all, you need to be able to attach them to requests, to HTTP requests that come and go from App Engine, no, from the Android. Okay, and here I can give you sample code. It's actually not that complicated. Okay, but I forgot how to do it. I mean, I don't know it by heart. I can tell you that there is a. What you do is basically you create an HTTP form and you set the content of that form to be an appended file that is that, to do the upload. And to do the download, I forgot, but I've done it at some point, and so I knew how to do it. And so I just need to fish out the code that I was doing in order to download the picture. Okay. So on that I can give you some sample code. It's not particularly difficult. What would be difficult is to do multi-part uploads. So doing attaching multiple files to the same post request. You probably don't need to do that. Right? You can send them one by one. So sending them up, you essentially do a post request, and the only small detail is that you need to attach a file. So how do you get the picture? Where do you get the picture from in Android?
They would take a picture and save that file.
Okay, so that's the easy part actually. It's not that complicated, because if the picture is not taken in your app, right? You use an intent for the camera app, right? That's the easy part, because when you use an intent to the camera, what you get back is a file that contains the description, is a URI that tells you where the file is. And so you can directly use that. The only thing that you have to be careful about is that you need to, I mean, either there are two cases. One is that the picture is of general interest for the user and you can leave it there on the phone forever. That's the easiest. If it's taken for a very, very special purpose for your app, at some point you need to delete it. Maybe on successful upload. That's your decision. But even that is not very complicated, because again, you know, I don't know the command by heart, but if you search, there is a way to delete a file given the URI. No, so that's the sort of easy part. The more difficult part, I mean, it's not incredibly difficult, but the sort of nasty part is what to do with the image uploaded once you are on a server. And I can tell you the easiest way by far would be not to use App Engine in this case, not to use Google App Engine, but to use something like Python Anywhere as the server. Because in that case, you would be able to do the following. You would be able to do db define table pictures, okay, where the table would have essentially this format. It would have like a field name, just, you know, I don't know, for the fun of it, but we don't care so much, okay? And then field picture, okay, pic, and the type would be upload. And actually, this is all you need, okay? And then there is a way to define an upload form and have the picture stored there. Okay, so the documentation is in, I wonder if I should, because Web2Py is written with the belief that it has to produce a form for you. In this case, you don't have a form. Okay, so I can, yeah, I can look it up a moment and I can come up with the code. Okay, I don't know that I can do it instantly. I'm wondering whether, so where I can tell you where I would look. Okay, if I did this, I would look in Web2Py upload file upload. There is a place where this is explained. Maybe here, but the point is that Web2Py tries to help you a lot and believes it's already producing the form for you that works in the right way. Here you're not producing a web form because the upload comes from Android, so it's slightly different. That's why I don't know by heart how to do it. But I can come up with the small amount of code that does it. Okay. Now this lets you do it on Python Anywhere. The real difficulty is for you to do it, but this is not required for you for the class, so this is only for your curiosity. But the real difficulty is this. Great, on Python Anywhere, you know, they give me a machine that has some database, but if I start stuffing images into it, pretty soon the database becomes too large. So, you know, what's a really good way, not any way, but what's a good way of actually storing images in the cloud? Okay, that's a real problem. And so there are sort of two answers. Okay, I mean, there are incredibly many answers. The truth is, if you want to use Google services, there are two ways in which you can achieve this in a semi-pleasant way. Essentially, you can decide that the images go either in a thing called the blob store or in a thing called the Google Cloud Storage. Okay, in the end, the two of them are quite similar, but using them, so the blob store, using it is a little bit complicated. Okay, if you want to use the blob store plus Google App Engine, the best you can do is look at the Alfaro personal page, like maybe I don't know, Web2Py. I have a personal web page somewhere. Maybe here. okay, and uploading files to the Google Blob Store, and you can read how to do it. Okay, this gives you actually the code in detail for doing it, but it's not particularly simple code, as you can see. Okay, because let me tell you why it's complicated code. Because what happens in the end is something like this. Here there is your Android. Here there is the blob store service that can store blobs. Okay, so it has already a few, and you are going to add one. And here is instead App Engine, which is trying to serve your web request. What is really happening behind the scenes is this. I'm going to give you a special URL. This is a URL that is quite long, and it's one time only. Okay, so I don't tell you upload by accessing this URL, which is my classical URL. You have to access a page, and they give you this special URL back. It's a very long URL. Now you can do a post to this URL. You do a post to this URL. Okay, to this long URL, and this post takes you to the blob store. So the post to which you attach the image doesn't go to App Engine; it goes to the blob store, which is a separate set of computers sitting in a in a different. The image is then stored here, okay? And how does a post work? A post is essentially there is a series of variables that have values and a file attached. So maybe your variables was like name is equal to Bob, etc., etc., etc. Okay, and then there was this big image. This is how this post looks like. Instead, when it gets here, the image is stored, and the blob store makes a request on your behalf to App Engine that looks like this. Okay, the name is equal to Bob. Okay, and then it adds a field that is like called the blob key. It is equal to, and this points to where the image has been inserted, okay? So this is passed to App Engine, and App Engine now needs to store, hey, there is now something called Bob that has this blob key. Okay, so App Engine only sees the blob key, which is quite small. I don't know, 150 bytes or something like that. Okay? So, and App Engine, when it wants to give you the picture, what it does, it says, please attach the blob with this key to my response. And so, I attach the picture to you in the response. But managing this code, getting this code right is difficult. I mean, it took me a considerable amount of time because it's not well documented, this whole process. And it has many hidden failure modes, unfortunately. Because, your upload may be truncated, it may be empty, it may be this, it may be that, this may be offline, this may be not, this may be whatever. And so, taking care of all the cases is not easy. And so, I mean, you are highly recommended to look at that if you ever want to implement that. The advantage of that solution, so you may find it unbelievably complex, okay? And you say, this is just crazy. The advantage of that is that it costs next to nothing, okay? First 5 gigabytes are free, and thereafter is 0.0009 gig per gigabyte per day. So that's how I store all the homework that not only you, but everybody has ever submitted in CodeGrader, and they have yet to pay a cent. Okay? So there is a really big advantage if you go up for, if you want to do something scalable. The other thing you can do is use Google Storage. And Google Storage, there are two, or Amazon S3. Google Storage has two ways of being used. One is through a similar way like this, which still you're doing this very complicated thing. The other way that I suspect works, and maybe that would be a fantastic way, would be this. Same for Amazon S3, by the way. I think you can create a bucket. It would be not very security, not great for security at all, though. Because what you could do is you could create a bucket to which anybody can write. And so your phone could do a post request to that bucket with a photo. It would create a file in that bucket. What is a bucket? A bucket is like a directory. It's only that directories are hierarchical, some buckets are not, right? Buckets are, every bucket has a name, they have to be globally unique. So I do a bucket that is called my app attempt number 1, whatever name you choose for your bucket. Then you can upload photo to the photo to that bucket, and then the phone receives back probably the name of the photo it has uploaded, or you can just choose a very long random string as the name of the photo. And then you can do a second separate request to App Engine or to whatever server you have, in which you just give to the server the URI, I mean the URL of the image you have just uploaded. Okay? If you could get buckets on S3 or on Google that give the right to read and write to everybody, but not the right to list the bucket content, you would almost be in shape. Okay? Because the idea is that if you use a really long random names, say 256 random characters for the names of the images, the chance that you guess the name of the image belonging to somebody else is really low. And so, you know, that's good security. Your cookies are done in a similar way, you know. Your cookies that get access to Facebook, Google, every web service are just long random strings. So, you know, if you could reliably guess somebody else's cookie, you could log in as them. So in reality, there is no better security than security by making problems rare. And that's the best you can hope anyways, you know, because, you know, in a rare case, we are hit by an asteroid, I guess, or we are run over by a truck. And so, and so, you know, all we can hope is, you know, statistical safety. So that could probably be an easier way. Okay, and those are my 2 best suggestions for storing images. Does this help at least a little bit?
Yes.
I mean, this code works, okay? I mean, I debugged it all and it really works. So I mean, that's what I essentially did. I had such a pain developing code grader that I thought I would render a public service by posting this snippet of code because it wasn't really documented anywhere how to do this. Because Google assumes that you use develop on top of their web app, which is really not a very full-featured web development framework. And so, you know, I sort of reverse engineered and I did in Web2Py, but yeah, it's complex. Any other question? Yeah?
Quick. Our team is developing something with maps, and to use that, you need API key, which requires that you have the key store that you use is like registered. But if we're all developing, and then your debug, when you debug, that has its own signature, some signature key. So we all are developing it, and we all have our development gardens, and we all run it. But if we're passing it around to Git, manifest has one key. Is there like a decent way if you have this kind of problem?
I this with my team, we do the same maps stuff.
Yeah.
There's when you get a key, you can input multiple SH1, SHA1 strings.
Okay.
So that the one key will work for all of you.
Oh, okay. Okay, that's so even my keeping my signature, like my release key and my not my release key, my release signature and my debug signature both being
Okay, no, I haven't developed maps recently, so I thought the question was how to keep the key file out of Git. That's easy, of course.
Yeah, just exclude it.
Yeah, but
But if you have to patch out the manifest, it's the
yeah. Yeah.
For Simon 3, a friend of mine looked at what we did with the services because they had done it with Android and asked if I had it on GitHub, and it didn't because since a lot of that is your code. Would it bother you if that was up there?
My code is already on GitHub.
But I mean, like, you'd be under my name. You know, it's like my.
Well, no, I mean, yeah, I should always give you a lecture on sorry, the name. Licenses, right?
Right?
So I put it there with a BSD license, if you notice. So essentially, you can take the code, put it in your GitHub, or do whatever you like, as long as you preserve that license.
Okay.
Oh, Okay, and if you modify it extensively, what you should be doing is that you should add yourself to the authors system. I mean, that's the procedure for the BSD license under which is released. I think you know much about licenses already, so I'm not sure it's useful to cover some of that. But yeah, that's the way it works. Yeah, originally, by the way, I had a wrong copyright on that file, but it's really my copyright. Yeah. Yeah, no, absolutely. Any other question? I'm glad, in fact, that that code is helpful.
Yeah, it was out there, and like I could rewrite maybe different. But
You can fork my repository, I guess, but you can
Yeah.
fork it as you on GitHub or do as you like. Yeah. Okay. Well, let's stop the broadcast.